Welcome to SST College of Arts and Commerce. This is SST Edupedia. Myself, Assistant Professor Yogesh Patil from the Department of Information Technology and Computer Science. Today we are going to discuss the topic analog transmission and its second part. This is for SYBSc, for IT it is for same third, and for computer science it is for same fourth, and the subject is computer networks. So friends, let's start. Analog and digital transmission, we have already discussed how to convert digital data into analog signals. So friends, analog to analog conversion is nothing but the representation of analog information by an analog signal. So here one may can ask that why we need to modulate an analog signal. It is already analog. So let's see one basic example, that as we speak on a mic, the signal is, or a voice data is converted to the analog signal, and it has been carried through the wires up to towards the speaker. So data has been carried from one location to another location. So modulation is needed if the medium is bypass in the nature, or if only bypass channel is available for us. So we are going to discuss in this session about the different modulation technique, that is amplitude modulation, frequency modulation and phase modulation. As we know that in digital to analog signal conversion we have three different types, that is ASK, FSK and PSK, that is amplitude shift keying, frequency shift keying and phase shift keying. Depending upon the amplitude, frequency and phase, we are modulating the signals as well. So these are three basic types of analog to analog conversion, that is amplitude modulation, frequency modulation and phase modulation. Let's discuss the amplitude modulation. So in amplitude modulation, a carrier signal is modulated only in amplitude value, and the modulating signal is the envelope of the carrier. So the signal or data is just put into that modulation, and the required bandwidth is 2 bit, where B is nothing but the bandwidth of modulating signal. Since on the both side of the carrier frequency FC the spectrum is identical, we can discard one half, thus requiring a smaller bandwidth offered for the transmission. We will explain, or we will see with the help of diagrams. As you can see in the diagram, here we have modulating signals, the actual signal as you can say, then the carrier frequency is also defined. The carrier frequency is nothing but the frequency of the channel, and as per depending upon the frequency of the channel we are modulating the signals, and the modulated signal will be look like the below signal. The frequency or a modulation might be a difference, and then it has been modulated with the help of multiplier or an oscillator. So FC, that is nothing but a frequency, is added to the signals, so which converted or which gives the bandwidth for this channel as well. So one thing we have to note, that the total bandwidth required for amplitude modulation can be determined from the bandwidth of the audio signal, that is BAM is equal to 2B. And as you can see in a diagram, if we have a spectrum of the frequency from 530 kilohertz to 700 kilohertz, so it has been sectionized in the different parts, that is nothing but 10 kilohertz. So frequency is sectioned in the different forms, that is, as you can see in a spectrum of blue and yellow pattern, we have bifurcated that frequency. Then let's discuss the frequency modulation. The modulating channel changes the frequency Fc of the carrier signal. Then the bandwidth for FM is high, and it is approximately 10 times higher a signal frequency. And we have to keep one note that the total bandwidth required for FM can be determined from the bandwidth of the audio signals. So B at the base FM is equal to 2 into bracket 1 plus beta bracket complete into B, where beta is nothing but usually having a value 4. Let's see in the diagram. As you can see in the diagram, a signal which having a frequency is modulated with the carrier frequency, and where we have the higher node or higher amplitude, it has been changed or the density is high, and where we have a lower amplitude, the density is low. So voltage has been controlled by the oscillator. So we have to need to use VCO, that is voltage controlled oscillator, for modulating the frequency of the given analog signals. So for the example, we can use this, or FM can be used for sending a radio channel signals as well. So as you can see, if the data is having frequency from 88 megahertz to 108 megahertz, so frequency lies in between that. A simple example, as you can see, one channel which is known as an Radio Mirchi or a Radio City 91.3 FM. So that 91.3 FM is nothing but the radio frequency of that particular channel. So as you can see, the frequency having some distance where we can adjust the channel to get or to receive that radio signals. Now what is mean by phase modulation? As you can see, phase modulation, in the phase modulation, the modulating signal only changes the phase of the carrier signal. The phase or a peak amplitude has been changed by the channel or a signal only. Then the phase changes manifest itself as a frequency change, but the instantaneous frequency change is proportional to the derivative of the amplitude. So the bandwidth is higher than the AM. So as you can see in this complete session, we have noticed one thing, that amplitude modulation having the lowest bandwidth as compared to any other type, that is whether it is frequency modulation or amplitude modulation, phase modulation. So as you can see in a phase modulation, when the higher data rate or a higher frequency signal arises, it merges with the carrier frequency, and the peak amplitude or phase modulation, it make the signal more dense at the higher density, but you can see the changes in the phase. So phase has been changed as per the frequency of the received analog signal, and we can use here a voice controlled oscillator for modulating the frequency of the or a phase modulation. So the formula which has been used for a phase modulation is, let's discuss, the total bandwidth which is required for phase modulation can be determined from the bandwidth and maximum amplitude of the modulating signals. So the formula, it gives that bandwidth for the phase modulation is equal to 2 into bracket 1 plus beta into bracket B. So here B is nothing but the bandwidth of the carrier frequency, and beta is having the almost 2 value for the often. So friends, we have discussed about the different type of analog to analog conversion, that is amplitude modulation, frequency modulation and phase modulation. So one thing we have noticed that the AM and FM has been used for radio frequency, as well as pH is used for sending or transmitting the phase of the given analog channel or analog signals. Thank you very much.